OpenSplice-Cache is a fully distributed caching technology. So this means there is no centralized server whatsoever, no centralized server for dealing with replication or management or indexing, nothing. So there is just no centralized server. It supports SQL queries on a local cache. So that means if you have an application running on this node, you can run a SQL query on this specific cache. And it also supports continuous queries on the all distributed cache. That means that if you have an application running on this other one cache, on this other node, it could register a continuous query, which is expressed, as we will see, by means of a SQL expression, but that then is applied to the all distributed cache. So that's very, very powerful. And you can see continuous query as some form of complex event processing. It is very high performance and ultra low latency, and this is because as the core for its coherence protocol, it uses OpenSplice-EDS, which is PrismTech record-breaking messaging layer. And then it also, as we will see, fully exploit data locality, so both spatial as well as temporal locality. In terms of architecture, as I was mentioning before, it leverages OpenSplice-EDS messaging technologies. So as you can see here, it is really built by extending the OpenSplice-EDS, although you would see this if you would open the box, because if you're not interested in pub/sub messaging, then you can write your application simply against the caching API. But the other side of it is that by being built on top of our high-performance pub/sub technology, we can also expose the pub/sub technology so that in the same application, you're able to mix and match, if you need, the real-time pub/sub and the caching application. So just to give an example, if you're building a financial application and you need to get from one side market data and on the other side cache orders, you can do the same. You can do all of this by using OpenSplice-Cache, because on one side you would be using the caching API for caching your orders, but on the other you would use the ultra-low latency OpenSplice-EDS real-time pub/sub for receiving stock updates and so on. In terms of API, the OpenSplice-Cache has been designed so to provide a core API that is very simple, I should say lean and mean, because our idea was to make sure that you could do 90% of your job in the most productive manner and in the most immediate manner. I will show you how simple is the API in a minute, but before doing that, it's also important to explain that we provide a rich set of extended API that allows you to rendezvous on a data item, that allows you to do advanced cache tuning and configuration, that enables you to set the quality of service for the specific data items that you are caching. So you can tune and change the quality of service, such as, let's say, persistence of a cache item per data item. And you can also play with things such as the cache replacement strategy. So in terms of the core API, we have a write, which, I mean, in terms of the basic write is very simple. So you write with a key a specific value, and this is inserted in the cache. Then we have two different reads. So you can read a key, or you can take a key. And the key difference is that when you read a key, then the value is retained in the cache, while when you take a key, then the value is removed from the cache. So you're actually freeing some memory. And then we have queries. So as I was mentioning briefly before, we have both traditional SQL queries. So you could run a query against your local cache, so the instance of the cache running on your node, and get back a view, or you could register a continuous query. And in this case, you provide a SQL expression as well as a listener. And this listener will be notified each time there is an object inserted in the cache that actually matches your SQL query. Then you can also add handlers and a notification handler. And these notification handlers are available for being notified on when there is a miss. So if something that you are trying to resolve is not found, then you could register a miss handler that is actually called by the middleware in order to try to resolve this data item, because it could go and fetch it from a database or maybe spawn a computation or something like that. And you can also register and insert handler. As we will see, we support prefetching, and there is an API for registering an handler that allows your application to decide how to customize and if to take advantage of prefetching. Okay, let's try to dig now into the architecture. And while preparing these slides, I was thinking quite a bit of how to present or how to best present the architecture and our choices. And in the end, I decided the best way was to see how our architecture was actually designed so to theoretically optimize performance. And so the best way of showing that, I think, is to go through the typical equation that you would like to keep in mind when you want to evaluate the performance of a cache. Okay? And it is also important to understand the potential speed up or improvement that you could get when using our cache in a system that doesn't use a cache, or when using our caching technologies when replacing another caching technologies. So what matters for a cache is the average data access. Then, if you're also working in a real-time system, you know that what matters is also the worst case average data access. So in this case, we see that its component is given by the hit time, so the time that it takes to get a data item when you find it in the cache, plus the miss rate times the miss penalty. So the miss rate is essentially the probability of not finding something in the cache, and the miss penalty is the time it takes to actually get that amount of data. So to optimize the cache performance, you have to focus on optimizing then three things. You have to minimize the hit time, you have to reduce the miss rate, and you have to reduce the miss penalty as much as possible. Now, OpenSplice-Cache has been designed to ensure that all of these factors are indeed optimized. Let's try to see how. So with respect to the hit time, the hit time, again, is the time taken to access data when the data is in the cache. Now, in the concept of the OpenSplice-Cache, there are two different kinds of hit time that we need to distinguish. What we call the local hit time and what we call the remote hit time. So you experience the local hit time when trying to accessing a specific data value or a specific key. You find that value associated with that key on the cache instance running on your node, while you experience a remote hit time, as I'll show you with an animation, when this actual value is not available on your node, but is available somewhere on the network. Now, for how the protocol that we use internally are designed and the architecture of OpenSplice-Cache has been designed, the local hit time really is counted in microseconds, and the remote hit time is equivalent to a round trip on OpenSplice-VDS. And on OpenSplice-VDS, a round trip, depending on the message size, but for a small message size, is typically counted in tens of microseconds. So depending on your network and depending on the message size, it could be 100 microseconds or 150, depending on what you have and what you are shipping back and forth. So that's really, really fast, and I mean, there is no other cache that can do this today.